Hello students, these questions actually is from current electricity. So current electricity questions you have to practice quite a lot. So when you practice more, then you are able to do questions. I mean, for any lesson it would be like this, but for this actually you have to practice quite a lot. Then only you will understand the direction of current, how to allocate potentials and everything. So my advice is go through with these questions, try to do the question and see the answer. So likewise, try to do almost all the question. Then you will know what are the difficult areas you will find it difficult to do the question. So then you will know what to do next.
Basically, what you have to do is you have to try the question and go through the explanation. So I'll be discussing at least 10 to 15 questions here. So just try to learn from each question, and you will obviously learn something new, something for sure. So practice. Actually, this is actually for the practice purpose. So try doing questions. Practice is the key here. So let's start with the very first question. Try to find the current through the. What you have to find is you have to find the current through this circuit, basically I. Alright, what you have to do is you have to apply sigma equals sigma IR, that we call Kirchhoff laws. So 10 volt, sigma is 10, and I current, all these three resistors actually they are in series. You can see them one after the other. See, after 5 kilo ohms, then we have 2 kilo ohms, then we have 3 kilo ohms. All the current that is going through is same. So connecting these things, that means these three resistors are in series. So current will be I, and then 5 plus 2 plus 3, that will be 10. But remember that it's 10 kilo ohms. So 10 into 10 to the power 3, 10. So I equals 10, 10s cancel off, 1 into 10 to the power minus 3, that means 1 milliampere. Easy answer. Right, in the second question they are asking us to find I1. That's the total current here, see. That's the current they are asking from us. Right, right, and let's find the answer. Alright, how do you find the total resistance? To find the total resistance, actually we need to add them. So how do you add them? So initially these three resistors, see, 7, 1 and 10, these three are in series. See, now if you look at these resistors, 2 ohms, 7 ohms, these three might look like in series, but these two are not, because the current that comes over here I1, it doesn't go through these 7 ohms. Certain amount of it goes to 9 ohms as well. So we cannot consider 2 ohms and 7 ohms as series. So only series resistors we can see here is 7 ohms, 1 ohms and 10 ohms. See, one current goes to 7 ohms, and that the same current goes to 1 ohms, and the same current goes to 10 ohms. So only these three can be taken as series. Let's add them. 7, 8, 10. So that's 18. So we have here now 18 ohms. That 18 ohms and this 9 ohms starting from the same point and terminate at the other point. So we can consider this 9 ohms and 18 ohms, they are in parallel. So parallel 109 plus 118 equals 1 over. I hope you know the equation. Common denominator 18, here we get 1, here we get 2, 1, then 1 over. So let's take the reciprocal value, R equals 18 over 3, that makes 6 ohms. Now we can simplify the resistors. Now it's 6 ohms. So here we have 6 ohms resistor instead of the other resistors. We have 6 ohms here. Now we can see this 2 ohms, 6 ohms, 7 ohms. These three are in series. 2 plus 6, 8, 7, 15. So total resistance will be 15 ohms. So let's apply V equals IR for the circuit, then we can find the total current. I into 15, here 15, you can easily see I equals 1 ampere. That's our answer. Let's move into the second question now. Right, this is the third question. They are asking us to find I3, I1 and I2. Right, give it a try. Just try to find the answer first, and keep your answers ready, and let's go to the explanation now. Right, so they're asking us to find all these three currents, and 18 volt, that's the cell. So basically we can see these 6 ohms and all these three resistors are in parallel, right? So what I can do is I can add them for sure, and then I'll get the circuit. I can simplify the circuit into this some R value. So 1 over 6 plus 1 over 6 plus 1 over 6 equals 1 over R. So 6, 3, 1 over R, you take the reciprocal, that becomes 2 ohms. So here 2 ohms, and here we have 18 volt. 18 divided by 2, that's 9 amperes. That's the main current. Actually they are not asking us to find the main current. One thing you can see here is all these resistors are in parallel and the values are equal. That means the same current will flow through each of these resistors. So that's Kirchhoff laws. I equals I1 plus I2 plus I3. So same current, equal amount. So once these three added, that should be equal to 9 amperes. So basically it has to be 3 amperes. All these values should be 3 amperes. I hope you could find the answer. Let's move into the next question. Now we are in our fourth question. See, they are asking us to actually what are they asking us to find? Right, we are moving into the fourth question. They're asking us to find, little bit different from the third question actually. They're asking us to find the current, find the reading of the ammeter. So that means we need to find the current. We need to find the current through this. So current might go here, then moves down and goes up. Right, these forms, all these three are parallel. So we can simplify it like this. We can easily simplify this circuit into something like this. So here we have 2 volt and ammeter here, and the equivalent resistance 104 plus 104 plus 104, that's 3 over 4. Let's take the reciprocal value, that's 4 over 3. So here it's 4 over 3, and of course we have here 4 ohms. So the total current will flow through here, right? So it goes out from the cell and it comes back to the cell again. So total resistance, total current will flow through this ammeter, remember that. Then I, so these 4 ohms and these 4 by 3 all are, here we can see these two are in series, so we can easily add them. 4 plus 4 over 3, that's 12, 16 over 3 ohms. So what we have to do is we have to apply V equals IR here. V is 2, I, that's what we need to find. R basically 16 over 3. So I equals 3 into 2 divided by 16, 1 goes 8, 3 over 8 amperes. That's our answer. Right, we are in the fifth question now. Find the current through 3 ohms resistor. Right, so this current, let's find the total current first, I. So once we add 6, 3, you can see 6 and 3 are parallel. So 1 over 6 plus 1 over 3 equals 1 over R. Common denominator 6, it's 1, 2. You take the reciprocal value, 6 over 3, that's 2 ohms. So here we have 2 ohms. 2 plus 4, that is 6 ohms. The value of the cell is not given. What's the value of the cell? Value of the cell will be 18 volt. So let's find the value. 3, so it's 2 ohms plus 4 ohms, so it's 6 ohms once we add these two, and 80 volt. That's apply V equals IR. 18 divided by 6, that's 3 amperes. So up to here, up to this point, we get 3 amperes. From that, it will split into 2 parts, I1 plus I2. So I equals I1 plus I2. 3 equals I1 plus I2. Right. there are couple of methods that we can try to find the current through 3 ohms resistor. So 3 ohms and 6 ohms up to here we get 3 amperes. First method we can try, actually the ratio method, V equals IR. So you can see I and R proportionality, I equals V over R. So that's I proportional to 1 over R. So we can use this proportionality to find the answer. Now let's use the proportionality. I proportional to 1 over R. So 1 over 3 is to 1 over 6 ratio, current flows to it. So I'll multiply this by 6, you get 2 is to 1. That's the ratio. So 2 over 3 and 1 over 3. That's the fraction. So that multiplied 3, I get 2 amperes and 1 ampere. So this 2 ratio comes for the 3 ohms resistance, 6 ohms resistor. So 2 amperes. That's the answer. The current through 3 ohms resistor, it's 2 amperes. So you ability to apply the ratio method in current question, actually that's a skill. So you need to have that skill, you need to practice it. Remember that. Moving into the 6th question. Right now we are in the 6th question. In the given circuit, the galvanometer reads 0 here. The value of resistance R, these are. Right, if the galvanometer reads 0 means you can see this 2-volt cell will give an EMF towards this direction, and this 5-volt cell also will push some current towards this direction. So these two, yes, there's once these two comes along this path, actually there will be no current. That means the potential difference across, let's say this is A and this point B, potential difference across A and B will cancel off. That means by 5-volt cell it will create 2-volt potential difference across this R, and this particular cell also will create 2-volt obviously here. So potential difference across R is 2-volt. That's the reason there's no current flow through this 2-volt cell. Right, knowing that, we know the rest of the potential will be across these 6 kilo ohms, because you can see these.
Right, you have finished 5 questions now. I hope you have learned something. Go through the next 5 questions as well. There are 10 questions. Let's see how it goes.
All right, now we know potential difference across is 2, R is 2, so here it's 3 volt, and let's reconstruct the diagram again. So it will be something like this. It's 6 kilo ohms here, it's 6 kilo ohms, and here it's R, and the potential difference across it's 2 volt here. So rest of the potential it's 5 volt, so the rest of the potential it will be 3 volt across here. Right, so let's apply Vickers IR for R resistor. From that actually we can find the potential difference, the resistance of R. I of course we don't know, V2, right. So now the problem is we need to find the value of I here. So how do you find I? Let's apply Vickers IR for the 6 kilo ohms. V equals IR. So here it's 3 volt, I it's 6 kilo ohms, remember that, into I. So I equals 6 over 3, it's 0.5, and divided by kilo, so it's milliamperes, 0.5 milliamperes. 0.5 R2, so 2 divided by 0.5, that's 4. Remember that's divided by milliamperes, so that's kilo ohms, 4 kilo ohms here. The value of R is 4 kilo ohms, right. So here students actually dividing by kilo ohms, so the values will be in milliamperes. Remember these stops, and allocating the potential, all of these you should know. Right, moving into the next question. Right students, we are in our 7th question. If the internal resistance of the voltmeter is 600 ohms, find the reading of the voltmeter. Right, so actually in some questions, in many questions actually we are given an ideal voltmeter, but here it's not an ideal voltmeter. This voltmeter actually it has some resistance, actually bit of a lower resistance, 600 ohms. Remember that. So we have to assume we have another resistor here, 600 ohms. Right, let's find the answer. Just try it first, try to get the answer, then let's come up with our answer. I hope you have tried it now. Let's try it. Basically what we need to do is we need to find the potential difference across, let's say this is A and this is B, across AB. So what I am trying to do is I'm adding these two and find the total resistance across AB, and then I find the potential across AB. So I have to add these two first. So 120 and 180 ohms, these two are in series, one after the other. I hope you can see it. So once we add these two, that's 300 ohms. 300 ohms and 600 ohms, those two are parallel. So 1 over 600 plus 1 over 300. So 600 again common denominator. So we get 1 here, we get 2 here. 600 divided by 3, that's 200 ohms. Right. So the equivalent resistance between A and B will be 200 ohms. So if we simplify the diagram a little bit now, so it will be something like this now. Not something like this. Let's draw it again. We have 300 ohms here, and then we have 200 ohms somewhere here. So here it's 300 ohms, here it's 200 ohms, and we have to split it. Yeah, 60 volt is the total potential we have here. So I'm going to apply the ratio method here. 3:2 ratio, V proportional to R, remember that. To find the potential difference across AB, 200 ohms, so I'm going to apply the ratio method, 3:2 ratio. The fraction will be 3 divided by 5 and 2 divided by 5. Right, if you do not know how to find these fractional values when getting the answer, I have done a video on that. So please check in, please go through the current electricity playlist, you will find a one. Right, so 3 by 5 and 2 by 5. So we need to find the potential difference 2 by 5. So that multiplied by the total voltage 60, we get 60 will be 12 and 1 is 24 volts. So potential, the difference across the voltmeter will be 24 volts. So that's our answer. Right, if you could get the answer, that's great. That means you know theories. So follow through the other questions as well. So moving into the next question. Alright students, we are moving into the 8th question. So it's a bit of a different question. Find the potential at point A, C and B, and they have given the potential, it's grounded here at point E. Actually they are asking us to find point potentials. Right? Try the question first, try to get the answer, then go through the explanation. Alright, let's get into the question now. Here they are asking us to find the point potentials, and they have grounded one point actually, so the potential here is 0. If this point is 0, this point it should be 20 volt, because the potential difference across the cell is 20 volt they have given. And then each of these resistors will keep or will hold certain amount of potential, you should know that. So to find that, actually we need to apply resistance ratio method, or we need to find the current. So let's apply resistance ratio method here. So even to apply that, actually we need to make every resistors in series like this, then only we can apply resistance ratio method. So to simplify the circuit a bit, so we need to add these two. 6, 3, once we add these two, because these two are in series, it's 9 kilo ohms. And once we add 18 ohms and 9 kilo ohms, let's add them. These two are parallel, I hope you can see. 18 plus 1 over 9, 1 over R, common denominator 18, 1 plus 2, take the reciprocal, 18 over 3, it's 6. Remember, it's kilo ohms. So here it's kilo ohms, 6 kilo ohms. And this 4 kilo ohms somewhere here, and 10 kilo ohms here. So 6 plus 4, 10 and 20. So here we have 20 volt. So then we can allocate the potentials. Right. So ratios will be 10:6:4 and 20 volt. So we can simplify it a bit. 5:3:2. So let's get the fraction. 10 over 5, 3 over 5 over 10, 3 over 10 and 2 over 10, right? So multiplied by 20, so we get 20 10 volt, 6 volt and 4 volt. Now we have the potential kept by each of these resistors, right? Moving into the answer, so 10 kilo ohms will hold 10 volt. So here the potential current flows like this. So potential at D is greater than potential at A. So potential at D is 20. So 20 minus 10, this will keep 10 volt. So VA will be 10 volt. And remember B, across all these, once we add these two, that's 6 kilo ohms, and it will keep 6 volt. So 10 minus 6, so VB is lower because current flows in this direction. 10 minus 6, that's 4 volt. So now we have VA, that is 10 volt, and we have VB 10 minus 6, that's 4 volt. We need to find potential at C. So we need to apply the very same method. Across A and B, potential difference will be 6 volt, right? So that potential will be split into 6 and 3. So 6 is to 3 resistance ratio, 2 is to 1 ratio. The fraction will be 2 over 3 and 1 over 3. I'll multiply this by the total potential 6. So each of these 6 ohms will be getting 4 volt, and these 3 kilo ohms will be getting 2 volt. So potential here is 10. 10 minus 4, the potential at C will be 6 volt. So we see 6 volt. Right, we have all the answers. If you have got to the answers, that's great. You know theories. Right, we are in our 9th question. Right, in the given circuit, the value of R is, this value R is unknown, right? So we need to find the resistance here. And yes, all these other values are given: 10 ohms, 20 ohms and 60 ohms. And we are given the current as well. So by using all these values, we need to find R. Yes, try the question first and then go through the explanation. See whether you have got the correct answer. Right, let's move into the question now. So here first thing actually we need to do, I'm saying we need to add all these 3 resistors. So if let's say this point is A and this point is B, you know, all these resistors are parallel. 10 ohms in between A and B, and 20 ohms in between A and B. If this is A, this point also A, remember that it's connected with a wire, so potentials are same. So 60 ohms also between A and B point, right? So all these 3 resistors are parallel. So 1 over 10 plus 1 over 20 plus 1 over 60 equals 1 over common denominator 60. 1, 2, it's 6, right? Yeah, 6, 3, 6, 3 and 1. So 60 divided by 10, we get 6 ohms. So equivalent resistance will be 6 ohm. Now let's simplify the diagram a little bit. So here we have resistor R unknown. Once we add all these 3 together, we got 6 ohms. R unknown, and the current is 0.2 ampere. Remember that this current go through R and the 6 ohms as well. So once 12 volt. Once this 0.25 amperes goes through the 6 ohms, we can find the potential difference across 6 ohms. That's apply V equals IR. So VI 0.25, that into 6. So let's 104. 6, it's 1.5 volts. So potential difference across 6 ohms is 1.5 volts. So the rest of the potential will be across R, because these two are in series. So 12 minus 1.5, right? So that's 10.5 volt. And then we need to apply V equals IR for R. So V is 0.5, I of course 0.25 into R. So if this is 1 over 4, 10.5, R equals 4 into 10.5. So it's 42 ohms. We have got the value of R, right? If you could get the answer, that's great. Moving into the next question. Right, students, we are in our 10th question. Find the current through 4 ohms resistor. They are asking current through this 4 ohms resistor. Right, actually there are a couple of methods you can do to find the answer. Try your method first and then go through the explanation. You will find the answer, right? See whether your answer is correct. Right, let's get into the question. Actually I'm going to apply the potential divider method to find the answer. So what I am doing here is, say now these 4, these 2 and these 2 ohms, all these 3, remember this is where I can start the lesson. See now 3 ohms, 2 ohms, again I cannot connect. All others we cannot connect because we cannot differentiate whether these all these resistors are series or parallel. Only these 3 resistors we can easily add. So I'm starting from here. So once we add 2, 4 and again another 2, right? Yeah, 2, so it's 8 ohms. We have 8 ohms. That 8 ohms and the other 8 ohms, those 2 can be connected, right? Yeah. Let's say point A and point B. So we have another 8 ohms. So 8 ohms and 8 ohms, those 2 are parallel, right? So 108 plus 108, 1OR. You don't have to add them all the time. Remember that if the resistors are equal, we can divide it by 2. Of course, 8 over 2. So take the reciprocal, 8 divided by 2, that's 4 ohms. So we get another 4 between A and B. So in between, we can assume we have 4 ohms. We have 4 ohms. 2, 4, 2, again another 8, just like the very same previous question. So we get another 8. So another 8 ohms. That 8 ohms and this 8 ohms parallel and it forms another 4 ohms. So we get 4 ohms. So finally the circuit will be something like this. We have 3 ohms here, we have 4 ohms here, and we have 2 ohms here. We have 9 volt. So if we apply the potential divider, 3:4:2 ratio, so 3 over 3:4:2 ratio, it's 3 over 9, 4 over 9 and 2 over 9. Let's multiply all these by 9. So we are getting 3 volt, 4 volt and 2 volts. Across here we get 4 volt, right? Then across these 2, 4 and 2 again we have 4 volt. 2, 4, 2, right? 2, 4, 2, right? Correct. So 2, 4, 2. 2 is 2, 4 is 2, 2. So 1 is 2, 2 is 2, 1. So across this 4 we'll be getting, altogether we have 4 volt. Once we split 1 is to 2 is to, let's find the ratio, 1 over 4, 2 over 4 and 1 over 4. I hope this is clear. So multiply by 4 we get 1 volt, 2 volt and 1 volt, 2 volt and again 1 volt. So across this 4 volt it will be 2 volts. So across these A and B, it's 2 volt, right? 2 volts should be settled down across these 2 ohms, 4 ohms and 2 volt, right? We are getting closer to the answer. They are asking us the current through 4 ohms. So same current will flow through these 2 ohms, 4 ohms and 2 ohms. So across AB the potential will be 2 volt. So what can I do? So potential difference across all these 2, 4 and 2, it's 8 ohms into I. So potential is 2, 8 into I. So 2 divided by 8, 1 over 4 amperes. Or you can supply 25 amperes. That's the answer. Yes, there might be several methods that you can try to find the answer. Yes, somehow if you could get to the answer, that's perfect, great. Practice. So here I have given you 10 questions, students. So practice questions as much as possible. Go through all these 10 questions again, and if you couldn't do at least one question, that means you are lacking theories in that particular area. So fine, earlier try simple questions, then you can move into the difficult type of questions. I'm pretty sure you can easily do these questions, and try your best. Good luck. Students, there are plenty of questions given in the playlist, so why don't you go through the playlist and find questions from current Lexicity and try the questions. Here you can find there are many questions from current Lexicity actually. Finding equivalent resistance, finding point potentials if you find it difficult to find point potentials and all that, point potentials, interresistance of cell. You can cover almost all the theories from the questions actually. Not theory questions are not there, remember that. Only the questions we have from we have to learn it from the questions, remember that. So it's always better to practice with questions. Give it a try, students. Remember, practice makes you permanent. I mean, makes what you practice permanent. So you have to practice questions. So find questions from the playlist and give it a try.